Welcome to a new PYTHA tutorial in which we will look at further functions of the Parts menu. Simple geometric objects can be created in PYTHA directly by entering values. These are referred to as default parts and can be found in the Parts menu under the heading Default. The block is the default part that you will certainly use the most. We talk about it in detail in a separate tutorial. One part that is also used very frequently is the cylinder. This is required for round plates and rods, for example. The following default parts are also available in PYTHA: sphere, cone, ring, pyramid, and tube. As explained for the block, the default parts can be created interactively in PYTHA. To do this, simply hold down the left mouse button after activating the function and drag the part. As soon as you release the mouse button, the current size is used. An additional value must be entered for all default parts except the sphere. This is also done interactively. This second size is set by left-clicking. The properties of default parts can also be changed subsequently in PYTHA. To do this, right-click on the part. A context menu then opens. Select the Edit command. A dialog appears in which you can change the part position and the respective dimensions. The nice thing about this is that changes in this dialog are immediately visible in the graphics area. This allows you to familiarize yourself with the values by trying them out. For all round parts, you can also define segments. But what does that mean? Well, curves are approximated in PYTHA by flat faces or straight edges. This simplification makes three-dimensional construction much easier. The elements that form the rounding are called segments. For example, if I reduce the number of segments of this cylinder to 5, you can see that the rounding now only consists of 5 flat faces and looks very angular. I increase this value using the arrow keys. The more segments I use, the rounder the part looks, and the more perfectly it approximates an exact circle. However, you should bear in mind that a finer segmentation also creates more points, edges, and faces, and that such objects require more memory and, above all, more computing time. If you are planning to create large projects with a lot of details and parts, you should keep the number of segments as low as possible. Wherever PYTHA generates segments, you can control the number. If the function does not have its own query, PYTHA uses a default setting and generates 36 segments per full circle. This value can be changed via the Environment pull-down menu. In the Settings dialog. In the chapter Segments. Please note, the value in this dialog only affects new parts. It has no influence on the segmentation of existing elements. By the way, don't be confused by the roughness of what you see on the screen when using few segments. In visualizations, the segments are smoothened, and it goes without saying that you get a perfect circular arc on your CNC machine. The Edit dialog contains special functions for some parts. For example, you can create a truncated cone for the cone. Or add bumps to the ring. I delete all parts in my project except for the block and call the cylinder command in the Parts menu. First, a small dialog appears asking for the relative point and the axis orientation of the part. So far in our video, I had hidden this dialog with the check mark at the bottom here. This dialog appears for all default parts that have an axis and therefore a direction. I have activated bottom and pressed the parallel Z button. The input prompt appears and asks for the position of the base point. In the block tutorial, we take a detailed look at the various options for defining the base point. I therefore recommend that you watch this video straight away if you are not already familiar with it. I simply pick the center of this face with the left mouse button and define it as the base of the cylinder. A little tip at this point. If you want to pick the center of faces, solid mode must be activated here at the top. Otherwise, the mouse click will fall through the face and you will pick geometry that is located behind the face. Always make sure that the mouse cursor shows the desired element. After the base point has been set, height and radius appear in the input prompt. As with the block, I enter the desired dimensions separated by a comma. I do this in exactly the same way as the field here at the front demands. So first the height, then a comma to separate the values and then the radius. Enter. I move the cylinder a little to the side and call the cylinder command in the vertical menu again. This time I activate the center reference point in the dialog and repeat the other steps in the same way. If I switch to the side view and deactivate the solid mode, we can look inside the block. As you can see, the left cylinder stands on the block. We had placed its base point in the center of the face and selected bottom as the reference point. As the reference point of the cylinder lies on the picked base point, we get this result. The cylinder to the right, on the other hand, grows out of the center of the face on both sides. This happens because we have chosen the center of the cylinder as the reference point, and this is placed in the picked base point. For both cylinders, we have specified the axis orientation parallel to the Z-axis in the dialog. If I create a new cylinder with these settings, here in the center of the front face, the result is not a meaningful construction. The cylinder axis does not match the orientation of the face. I undo the step with undo and draw a new cylinder. When looking at the coordinate axes, I see that the green y-axis points in the direction in which the cylinder axis should also point. So this time I choose parallel y. After I have picked the base point again with the left mouse button in the center of the face, the question about height and radius appears in the input prompt. I confirm the suggested value with Enter or the middle mouse button. The new cylinder is visible. However, the result does not yet correspond to my idea, because if I deactivate the solid mode again, you can see that the cylinder protrudes into the block, but I want it to be placed on its surface. I press the undo button to remove the cylinder again and repeat the steps. In the block tutorial, I describe in detail that the direction in which a part grows can be influenced by a positive or negative numerical value. The same applies here with the cylinder. So if I enter a negative value for height, the cylinder grows in a negative y direction and sits neatly on the surface of the block. I activate the cylinder command again and this time select parallel X. I pick this face center as the base point. As this cylinder should also grow in a negative axial direction, I again use a negative value for height. I delete the two cylinders here at the top and start the cylinder command again. Now I activate the user axis function. As before, the input prompt says base point. I select this corner point with the left mouse button As soon as I have picked it, a new text appears in the input prompt, "Pick second point." Now I pick this corner point. The input prompt appears again and asks for the radius. I type 20 and press Enter. As you can see, the cylinder is fitted between the two picked points. I therefore did not have to enter a height. By the way, if the desired settings are already active in the Relative Point Axis dialog, you can simply skip it with the middle mouse button. You do not need to press the OK button in the dialog. I also mentioned at the beginning that you can permanently hide the dialog with this small check mark. New cylinders are then always created with the settings that the dialog had when the check mark was set. So here with free axis and reference point at the bottom. If you need the dialog again, right-click on the cylinder button in the vertical menu and select the Reactivate its dialog command in the context menu. I have shown you how to enter values using the cylinder as an example. It is identical for all other default parts. Only the requested dimensions differ depending on the geometry to be created. For the geometry enthusiasts among you, PYTHA provides still more default parts that can also be created in the manner described above. These are the platonic solids, tetrahedron, hexahedron, which is also known as a cube, the octahedron, dodecahedron, and icosahedron. Derived from these solids, even geospheres can be created in PYTHA at the touch of a button. PYTHA also provides all Archimedean solids as default parts. In combination with other PYTHA commands, you can create great design objects or dome structures with these geometric shapes. I hope you enjoyed trying out the functions and look forward to seeing you at our next tutorial.